This is simplifying square roots method number 2. Again, I have created method number 1. There are 2 ways to simplify square roots. And again, this is not calculating square roots. This is not estimating square roots. This is literally simplifying square roots. This way, it takes a little bit longer to do method number 2, but it always works. And it's a way that you're familiar with. All right, to simplify the square root of 24, if you think about breaking it down to prime numbers, and you did this way back in the day, probably 6th grade, 7th grade, and you started doing like the tree method. And you divide by 2, and that's 12. You divide by 2 again, 6. Divide by 2 again, that's 3. So your prime numbers would be 2, 2, 2, and 3. So if you multiply these numbers together, 2 times 2 times 2 times 3, that will equal 24. And so you break it down to prime numbers. Well, so the square root of 24 is the same thing as the square root of 2 times the square root of 2 times the square root of 2 times the square root of 3. And so again, if you multiply these together, it will equal the square root of 24. Well, here's what you want to do after you did that, break it down to prime numbers. Look for any pairs that you see. Notice I have a pair of square root of 2's. Square root of 2 times the square root of 2 is the square root of 4. The square root of 4, I know, is just 2. And then these square roots, again, they can't be simplified, so I'm just going to multiply them back together. So 2 square root of 6 is your final simplified answer. Let's try another one. Again, we're going to break down 54 into some prime numbers. And you don't have to show this. This is something that, if you need to show it, then show it. But I expect that you should be able to do the prime factorization, most of it in your head, so you don't need to do that. So the square root of 54 is the same thing as the square root of 2 times the square root of 3 times the square root of 3 times the square root of 3. And again, you can multiply those together. That will equal 54. And I'm going to look for any pairs that I see. I notice a pair of square root of 3's. Well, the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is just 3. And then what's left over is I have a square root of 2 and a square root of 3. I'm going to multiply those back together to the square root of 6. Again, that's the simplified version of square root of 54. The square root of 125. Again, do the prime factorization if you need to, but that's square root of 5 times square root of 5 times square root of 5. Look for any pairs that you see. Square root of 5 times square root of 5 is the square root of 25. And the square root of 25 is 5. Again, that's the simplified version of the square root of 125. The square root of 80. Sorry about that. The square root of 80, if you break that down to prime numbers, the square root of 2 times 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 the square root of 5. And you're going to look for any pairs that you see. The square root of 2 times the square root of 2 is the square root of 4. The square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. The square root of 4 is 2. And then these are just normal 2 times 2. So that would be 4 square root of 5. That's the simplified version of square root of 80. Again, hopefully that's method number 2. If you don't like this method, you again go back to method number 1 and try either one of those. But that's